Okay, since there was not a video for this, I'm going to go make one real quick. When it says solve by factoring, I'm going to do that. And the first thing I always look for is a GCF, greatest common factor, or as I call it, the gotta check first. In this problem, I see that they both have a 5x in them, so I'm going to divide that out of each piece. Here the 5's cancel, I would have 1x left over. Here the x's cancel entirely, and I would have a 7. But I'm trying to make them equal 0. So for 5x to be 0, x would have to be 0. And for x minus 7 to equal 0, x would have to be 7. So those are my solutions. This has 3 pieces. So this is going to be where I go to my red card and I look at my options for 18. And I'm looking for a way for them to subtract to be 3. So 3 and 6 are my options. That was kind of an aggressive little parenthesis there. And then I look here and say I need it to be a negative 3. So I would need minus 6 plus 3. Those are my factors, but to get them equal to 0, I would need this to be negative 3. And to get this to equal 0, I would need it to be 6. Same thinking here, because it's 3 parts. I go to my red card, I look through all my options for 12, and they have to subtract to be 4. So I got to pick 2 and 6. I need it to add up to positive 4, so I would need a positive 6 and a minus 2. And then to make this equal 0, x would be 2. And to make this equal 0, x would have to be negative 6. So those are my solutions. This one's telling me to do square roots. I do not get decimals here, so I'm going to have to use my square roots. So I'm going to end up with x squared equals 25, because you have to get the squared part alone, and then you put in a square root, adding a plus or minus to your number side. So x is going to equal plus or minus the square root of 25, which happens to be a perfect square. So that comes out as plus or minus 5. Here I need to get the x squared alone, so I'm going to start by adding 6. 2x squared equals 50. I still have to get the 2 out of there. Now I finally have my x squared alone, so I'm going to bust out my square root, remembering plus minus, and this one, weirdly enough, is also plus or minus the square root of 5. Won't always happen that way. Here I need to get the squared part alone, but that's this whole thing, so I'm going to add 4 over here. Now I'll have this equals 25. I need to divide by that 5 because I'm trying to get the squared part alone, which I now have, x minus 2 squared. Now I'm going to square root, and on this side do my plus or minus. That will cancel out the square, and I'll have x minus 2 equals plus or minus the square root of 5, because 5 does not have any perfect squares in it. I can't simplify it any further. But I'm not done because I need x alone. So to get x alone, I have to add 2. So x equals plus or minus root 5, and then add 2 to that. And I can't really do that because I'm not supposed to get decimals, so I leave my answer in that form. All right, now they're telling me to use quadratic formula, so I'm going to go ahead and do that. So I'm going to identify my A, my B, and my C, and I'm going to do x equals the opposite of the b that they gave me. I'm going to use the positive version of my b squared, minus 4 times a times c all over 2 times a. And then I'm going to only do this part, not with a square root sign. I'm not going to touch that, but I'm just going to do the part under. So 2 squared minus 4 times 3 times negative 1. I'm getting 16. So negative 2 plus or minus the square root of 16, and then on the bottom 2 times 3 is 6. Then your job is to analyze this part with your red card to see what you can do. Well, that's a perfect square. So in this case, negative 2 plus or minus 4 over 6. And because those are numbers, you actually have to do the work, like negative 2 plus 4 over 6 and negative 2 minus 4 over 6. This becomes negative 6 over 6, so one of my answers is negative 1. This becomes 2 over 6, so my other answer reduces to 1/3. So if you got a perfect square underneath the radical, you should come out with regular numbers, not square roots or i's or anything. All right, round 2, my A is 3, my b is 6, my c is 2. Opposite of b plus or minus the square root of my positive b squared minus 4ac all over 2 times a. And this is the only part I'm doing in my calculator. So 6 squared minus 4 times 3 times 2, I'm getting 12. Okay, so negative 6 plus or minus root 12, and on the bottom 2 times 3 is 6. Going to my red card, now what I'm looking for is any perfect squares. Since 4 is a perfect square, that means I need to break my root 12 into root 4 and then its unsquared partner. This will come out as a 2. So this is going in place of that. So negative 6 plus or minus 2 root 3 all over 6. And then at the very last part, I check to see with my little triangle if any of the numbers outside of the radical, if they all can be divided by something. So for example, these can all divide by 2. So I get negative 3 plus or minus, and then 2 root 3 divided by 2 will leave me just 1 root 3. And then on the bottom, 6 divided by 2 will leave me with a 3 as well. So this is an example when that number under the square root was not a perfect square, but it contained a perfect square, so I had to simplify it. One more round with the quadratic formula. A is 2, B is 6, and C is 5. So the opposite of b plus or minus the square root of my positive b squared minus 4 times a times c all over 2 times a. Again, I'm only going to do this part on my calculator. So 6 squared minus 4 times 2 times 5, and that is kicking out a negative 4. Okay, I know how to do square roots of negative. 2 times 2 on the bottom is a 4. But just like every other problem with quadratic, it's my job to think about how to simplify this. So it's a negative and it's a 4. 4 comes out as 2 and that negative comes out as 2i. So I'm replacing that radical negative 4i with a 2, I'm replacing the square root of negative 4 with the 2i in that problem. And then just like in the previous problem, I'm seeing that these all divide by 2. So my final answer is negative 6 divided by 2, 2i divided by 2, over 4 divided by 2. And those are all the possibilities with a quadratic. You might get a perfect square, you might get something that does have a square in it, and you might get something that is negative, so therefore you should have an I in your answer. Okay, here simplify. There's a billion things you do when you're simplifying, so you just need to know what to do in each case. Here I'm looking to see if there's anything that can be a perfect square and can come out. So I'm looking at my red card and I'm seeing that 4 is a square, so I can split this into 4 and 6. The 4 comes out as a 2 and the 6 stays under. Same concept here. I'm looking on my card and I'm seeing these options. 25 is my perfect square, so I split it into the perfect square and its not square partner. This 25, the square root of that is regular 5, and this 2 is stuck under. When you have this big fat square root, you can separate them. 25, the square root of that is 5. On the bottom, the square root of that is 3. So you end up without any squares roots in your answer because they were perfect squares. Here, I got to get rid of the square root on the bottom, and the way to get rid of a square root of 11 is to use the square root of 11. It couldn't just disappear like my 9 did over here because it's not a perfect square. The square root of any number times the same thing is going to be that number but without the square. So on the bottom, it turns into regular 11. But on the top, the 3 and the 11 don't actually multiply because one's outside the radical and one's inside. So that is my final answer. In E, it's a fraction, so I can split them up. And I don't have to get rid of the one on the bottom because it gets rid of itself since that's a perfect square. And then this is just the same as thinking about the square root of 4, but because it was negative, I got to have that I in my answer also. Okay, here I need to know how to do this and what to do when I see it, and I'm going to need to use the conjugate. So the conjugate of this is 2 plus root 3. Same thing on the top. So when I distribute on the top, I'm going to get 6 plus 3 root 3, but the bottom should come out to equal a number. So I'm going to FOIL the bottom, 4. Here I'll have 2 root 3, but here it will be negative 2 root 3. Here, negative times positive is negative. Root 3 times root 3 is root 9, but that's going to really just be 3. So this is gone because it's a perfect square, and these two are gone because they cancel one another out. So all I have on the bottom is 4 minus 3, but 4 minus 3 is 1, so you can write it in your answer or you don't have to because something over 1 is just the top part. Here, it looks like I'm distributing. I'll have 2 root 3 times root 3, so that is going to turn into root 9. And then here, I just have to take 2 times 1, so that stays 2 root 3. But you are not done, and it's your job to realize that this is a perfect square, so that can come out as a regular 3. And now that they're both regular numbers, they can multiply to be 6, and then the 2 root 3 cannot be added to it because it has that radical, so you can't add the 6 and the 2. It would be like having 6 plus 2x. Looking at this, I need to realize that since these are multiplied, I'm going to go ahead and FOIL them. So I'm going to do 3 plus 1 times root 2 minus 3 times root 2, and then here minus the square root of 4 because root 2 times root 2. But this can cancel out to become a regular 2 because that's a perfect square. These don't cancel, but they do combine. So like the number part is 3 minus 2, which is 1. And here I have 1 root 2 minus 3 root 2, which would leave me with negative 2 root 2. So with these FOIL problems, you should end up with just one real number and then one radical number potentially. All right. This is just saying you might get i's in your answer. So the square root of 49, 49 is a perfect square, so that comes out as 7. But the fact that you had a negative in there means it comes out with an I. Here, it's not a perfect square, but if you look at your options on the red sheet, you have a perfect square in there. So you split it up and think, okay, there's a negative, there's a 4, and there's a 3 in there. The 4 can come out as a 2, the negative comes out as an I, and the root 3 is stuck inside. Here, you have to change this to 2i, and you have to change this to 3i first, because that's the square root of a negative and 4, so 2i. This is the square root of a negative and 9, so 3i. Then when you multiply them together, you get 6i squared, but I is negative 1, so your answer is negative 6. So change them into their I form before you actually multiply them together. Here, I am not FOILing. See this right here? I am just combining like terms. So 4 plus 2 is 6, and negative 2i minus 9 more I is negative 11i. You will not FOIL this because it is adding or subtracting. So you're just combining like terms. Same thing here, except this negative distributes, so I'd have negative 4 and then plus 3i because these negatives would cancel. So I'm just combining like terms. Here I have a 4 and a minus 4, which actually cancel. So I'm only left with 2i plus 3i, so 5i. You can put 0 if you want to, since you had 0 real parts left, but you don't have to. Now I'm going to FOIL. And the way I know I'm going to FOIL here is there's nothing in between them, so it's multiplying. So 3 times 2, 3 times negative 4i, 2 times 2i, and 2i times negative 4i. Be careful, because that has an I squared, since it was 2i times 4i. So that becomes this, which becomes a positive 8, and can now combine with the 6 to make 14. And then the part that has i's in them, these two can combine. Negative 12 plus 4 would be negative 8i. Okay, here I'm back to distributing, but it looks tricky because of the negatives. So negative 2 times negative 4 will be negative 8 root 3. Here the negatives will cancel. 2 times 2 will be 4, and inside 3 times 5 will be 15. If I look at my card for 15, these are my only options, and none of these are squares. So I actually can't do anything more. I can't add them because they don't have the same number under the radical, and I can't break either of those down, so that's my final answer. Here, to get rid of an I on the bottom, I need the conjugate, so that would be a negative 3I. Because remember, 3I would be like 0 plus 3I, so its conjugate would be 0 minus 3I. In the top, those two cancel and turn into 6I, but on the bottom, you get negative 9I squared, but keep in mind that I squared is negative 1, so those multiply to be a 9 on the bottom, which can reduce to 2I over 3, and that is your best right answer. Here, I have to use the conjugate, which would be 4 minus 2I, and I have to do the same thing on the top. The bottom should turn into a number. The top can be as ugly as it wants. So I'm going to FOIL the top. And I have to FOIL because I have two sets of parentheses. So I'm going to get 12 minus 6I minus 4I. Here the negatives cancel and I get 2I squared. But I squared is negative 1, so this is minus 2. So 12 minus 2 gives me a 10 on the top. And then these two, negative 6I minus 5 more, or 4 more, is going to be negative 10I. On the bottom, I'm going to FOIL that, and I expect to get a number because they are conjugates. So 4 plus 2I, 4 minus 2I, I get 16. Outside is negative 8I, but the inside is positive 8I. And then this will turn into negative 4I squared. But I squared is negative 1, so those become a positive 4, which goes with 16, and these cancel. So I get 20 on the bottom, 16 plus 4. But looking at these, a 10 can divide out of everything. So when I write my answer, 10 over 10 will be 1, 10I divided by 10 will be 1I, and on the bottom, 20 divided by 10 will be 2. So that's your best answer in reduced form. I'm running out of time because I'm making this during lunch. That one's not on the test, to be honest. So I'm going to go ahead and go to number 7, which is, and I really want you to focus on knowing how to do this. It tells you right here what to do. So you have a ball going in the air and coming down. This is the formula for that. It asks for the max height. That's right here. If you find the X part of your vertex, that's showing how far forward. If you find the Y part of your vertex, that's telling you the max height. So I need to do what we did way back at the beginning of the chapter. To find the X part, I'm going to take the opposite of my B over 2 times my A, and I'm going to make sure my calculator knows to do the two numbers on the bottom. So I'm going to put parentheses around that. And I am getting that the X part equals 0.71875. And then to find the Y part, which is what they're asking, I'm going to plug that number in to my equation that they gave me up above. So I'm going to have on my calculator negative 16.71875 squared plus 23 times 0.71875 and then plus 4. And I'm getting a negative number, so that can't be right. Let's try again. Negative 16.71875 squared plus 23 times 0.71875 plus 4. Aha! So I got 28.79 feet that it would go up. And then how long does it take to land? That's asking about over here. That's going to be the quadratic formula like it says. So I'm going to be taking x equals the opposite of my b value plus or minus the square root of my b value squared minus 4 times my a times my c from up here. A, b, and c. All over 2 times my a. And just like every single problem, I'm only going to do this part on my calculator. So 23 squared minus 4 times negative 16 times 4. So I have negative 23 plus or minus the square root of 785. And on the bottom, 2 times negative 16 is negative 32. So I'm going to do two things on my calculator. Negative 23 plus that square root. I'm going to get that answer and divide it by negative 32. And I'm going to do negative 23 minus that square root. Get that answer over negative 32, because that's what plus or minus means. One of these is going to give me a negative answer, which I have to rule out because I'm measuring time. So this turns into 5.018-ish over negative 32. And so when I get that answer, this time is negative 0.15. Can't have it. Sorry, too much talking. Here I'm getting that. If I divide it by negative 32, I get my answer. So before I choke to death, you're going to always get one positive and one negative. Choose the positive. Hope this helps. Bye.